Hello everyone, dear PC chairs and PC members. On behalf of all the authors, I would like to thank you for this great honor. We would have loved to be there to receive this award and make this talk in person, but unfortunately we knew this on very short notice, so we couldn't rush to be there with you. So we have been asked to make this short video, about 5 to 8 minutes, in order to highlight the main contribution of this paper. The idea here is, of course, not to go into the details of the paper, but more to answer the why we did it, and not specifically the how. So what this work is about, it goes actually back to the time where Benoit and I were passionate PhD students, both working on the topics of validation and execution of software processes. And at that time, the UMG issued a specification, a standard, called SPAM2. SPAM stands for Software System Process Engineering Metamol. And when we look back to the main motivations of this RFP, request for proposal, was actually to give a clear separation between what we call method contents, which is like, for instance, work products, roles, tasks, everything which could be related to a method, and the instantiations of these elements in a very specific development process. So this is a very quite nice idea. And also one of the main mandatory requirements of this RFP was the alignment of SPAM2 with the newly defined UML2. And at that time also people were start working on this foundation of executable UML. And finally, the last requirement of this RFP was that SPAM process model should be executable. And this is where Benoit and I were interested into contributing into this standard. So, but we look inside the standard, there are actually two options proposed for process enactment. So the first one was to propose an export to all those process management tools like Microsoft Project or IBM Rational Portfolio Manager. But the thing with this approach is, there is no concrete process execution. You just map your process model into MS Project, and then you need to add manually everything which is related to the instantiation of this very specific process, and of course you can't execute this process. And the second option that was proposed by the standard was to link some of your process elements with external behavior formalism like people, for instance, or activity diagrams. But still this was very vague, and there is no way to come up with a process execution by doing this. So, what we contributed in this paper, I'm not going to enter into the details. We won't have time, and I'm sure you have so much interesting stuff to see at the conference. But to highlight the main contributions were actually first giving a critical analysis of SPAM2. We identified some issues with the standard. And the second contribution was about defining what we call core SPAM in order to allow process enactments. Okay, so we call this package XSPAM core for executable software process models. And the third step of this contribution was dealing with extending this XSPAM core package with some elements that would allow process verification and execution of process models. Step number 4 was about exploring an approach in order to verify XSPAM process models. And finally, the step number 4 was trying to execute XSPAM process models. And for this, we propose two approaches. I will talk about them very briefly in the next slides. So, for step number 2, about defining XSPAM, we've been through the standard, and actually we identifying the core elements that we would need to define software process models. those elements, we would then extend them and enhance them in step number 2 in order to add some very specific attributes, concepts, relationships between those elements in order to take into consideration this notion of project association, process execution, the ability to monitor processes, and so on. So this is a very short example, for instance, how we extended the notion of activity in order to add some attributes about the state of the activity, about its importance in the process, about how to monitor the activity, how to start its execution, to stop it, and so on. And we did the same actually for all the process elements in order to allow a complete execution monitoring of this element during the process execution. For the step number 4, the verification of XPAM process models, here we relied on the fact that we wanted to translate actually XPAM semantics towards time Petri-net. Okay? The goal here is, of course, to reuse all the existing model checkers to be able to simulate SPAM or XPAM process models. And for that, we implemented a tool with EMF eCore, and we used some model transformations using the ATL language, and the model TINA model checker was used as a process verification tool. So just a big picture of this, we would associate XPAM process models, then we would transform them to have Petri-net models, and then we apply a model-to-text transformation in order to give something or to generate something that would be used by TINA, which is the model checker. We'll do the same for the properties and then check our process models if they would satisfy some properties. Step number 5 is about process execution, and in this case two approaches were explored. I'm not going to present the first one, which is actually the idea was to map XPAM process models toward a famous process execution language called Beeple, and we did this and we generated we call this step or this approach the compiled way. But still, before to execute the Beeple, we needed some configuration steps. There were some difficulties between the fact that due to the fact that there is a difference in abstraction levels between both languages and so on. And the second approach is what we call the XPAM execution model. So what is the idea of XPAM execution model is actually to define a behavioral semantics for the XPAM in terms of an execution model. If you already heard about foundation of executable UML, is actually almost the same thing, since we started to work on this as well at the very same time. The execution model would come with a set of classes, operations that would implement the precise semantics of XPAM elements. This was inspired by using, of course, the Gov visitor pattern, and for each XPAM element we would have at runtime an execution element that would simulate the behavior of this element. So just to show you a very small example, we would have this notion of activity, and then in front of it you will have in the XPAM executable model a class called activity execution, which would have all the operations and the implementation of this operation that would allow to simulate and execute an activity. Same thing for work seconds, we do it for all the elements, and we of course respected the semantics defined by UML activity diagrams and this notion of tokens going through the different nodes of the process model. So the results were actually pretty good. We defined what we call this time an interpreter for our process models that we used as a process engine, and we were able to have early feedback by making our process models executable, so we could straight away test and see what is happening, and if something is wrong we just modify the process model and test it again. We don't have to generate to a different language and then launch another compilation or interpretation step. And due to this fact that we have a strong coupling between the spam process models and their execution, we started thinking about the ability to go to another approach that would allow us to modify the process models on the fly. So that's it. Again, we would love to thank the PC chairs and the PC members for honoring us with this award. And we're still, Benoit and I, working on this area of process models, languages. And the funny thing is, we did this work in 2007. We were both PhD students, and 10 years after exactly, we became professors in the same area, and we're still working on this field. So thanks again, and we are sorry for not being there to receive this award, and see you maybe next year at APSEC. Thank you very much.